All right, hello once again, Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College AWD 1000 Web Development Technologies course, I've been creating a series of video presentations based on the Mozilla Developer Network Learn Web Development series. I'm in the JavaScript portion, and we're talking asynchronous programming, and we've gotten to promises. Now, as mentioned here, promises are a new style of async code that you'll see used in modern web application program interfaces. A good example is the Fetch API, which we're going to talk about much more later in the next lesson, in fact, which is basically like a modern, more efficient way of an XML HTTP request. Now, they give an example, but before we even go through that example, I found this online. I thought it was at least a good start. So a JavaScript promise can be in one of three states. Now think about it this way. If this confuses you, then kind of look at it this way. Let's suppose that it's a week before the semester starts. All right. And what we figure is that when you come to class the first day, I'll be there. All right, ready to teach you. So in other words, that's pending. It hasn't happened yet, so it's not fulfilled. It's not rejected. I'm in the pending state. Now, it's the first day of class, and if you walk in, I'm there. You could kind of say that that promise has been fulfilled. All right, that the operation was completed successfully. On the other hand, let's just suppose, and I hope this doesn't happen, that I get sick the first day of class. So you walk in there and I'm not there. Well, that would mean that your promise had been rejected. The operation failed. Now, just wanted to mention to you quickly here, it says there's an article here by medium.com. I pay $5 a month and I get unlimited access to articles on medium.com. And most of their articles are either about JavaScript or Android or things like that, and they're really good. All right. You may be able to look at some of this stuff and you may not, because they don't open up all their content to everybody. But they define a promise as an object that may produce a single value sometime in the future. So if it hasn't happened yet, it's not resolved. So either it'll give you a resolve value or a reason that it's not resolved. So again, as you already saw, then a promise can be in one of three possible states: pending, fulfilled, or rejected. And as it says, promise users can attach callbacks to handle the fulfilled value or the reason for the rejection. So once it happens that either it has been fulfilled, you can say that you want something to happen, or if it's been rejected, you want something to happen. And that's what they're starting to show here. All right. Now, it looks like we got some chaining going on here, because there's a dot then, and there's another dot then. All right. And this, I believe, is what's going to happen if the fetch worked correctly. So we're going to return it as JSON. Then we're going to set that JSON equal to products, and we're going to call initialize products. If this fails right here, we don't do any of this right there. Rather, we call the catch and we say fetch problem. All right. So when I tried running this last time, it gave me an error, so on a similar one. So let's look at this. All right. Oh, so they've got, okay, it's the code here. So let's do that. And again, this may work and it may not work. I'm not worried about that. You'll notice that this is not small. Wow. 188 lines. And it looks like at least it's all JavaScript. So let's come back into here and let's paste that right into here. Control S, and let's run it and see what, if anything, happens. All right, it says cannot load. You must use HTTP or HTTP request. I'm sorry, HTTP or HTTP secure, which is HTTPS, for a chorus request. So it failed to fetch. Now, that said, if we go back and try to run theirs, there it is. Choose a category. We've got all. What if we choose vegetables? All right, and we filter the results. Well, look what happened. All right, meat. Filter the results. Again, you can see what happened. Soup. Filter the results. Get that. And then finally, everything again, and filter the results. So it says we see fetch taking a single parameter, the URL of a resource, and that's probably why it failed, because I don't think I've got access to products.json. All right. The URL of a resource we want to fetch from a network and returning a promise. The promise, again, is an object that represents completion, which is what we were doing at first, or failure, which is the .catch. So this is the completion or the failure of an async operation. As mentioned, it represents an intermediate state, as it were. In essence, it's the browser's way of saying, I promise to get back to you with an answer as soon as I can. The concept, as it says, takes some getting used to. All right. Neither of the possible outcomes has happened yet. In other words, when it first runs, it's in the pending mode. So the fetch operation is currently waiting on the result of the browser trying to complete the operation at some point in time. We've then got 3 further code blocks chained onto the end of the fetch. There are 2 then blocks. As it mentions here, both of these contain a callback that will run if the previous operation succeeded. Each callback receives as input the result of the previous successful operation. That's the chaining. So I'm saying do this, then you're using basically the output of one operation as the input into the next operation. All right. Each .then block, as mentioned here, returns another promise, meaning that you can chain multiple .then blocks onto one another. So multiple asynchronous operations can be made to run in your order, one after the other. The catch block then, on the other hand, runs if the first or any of the then blocks fail. Again, this is similar in nature to a try-catch. All right. An error object is made available inside the catch, which can be used to report the kind of error that occurred. It says, note, however, that synchronous try-catch promise won't work with promises, although it will work with async await that we'll talk about a little bit later. Should mention right here too, I'm going off a little bit on a tangent. I don't want to too much. I'm at 9 minutes. But if I go out to YouTube, and there's a guy that I watch a lot, and I just because of the fact I think he does a really good job of this. All right, and that is, if you go out to Web Dev Simplified, there's the guy who runs this, his name is Kyle Cook. And the idea behind his website is, as it says, he wants to simplify everything that's on the web. So if I come out there and I type in promises, and I go out there, JavaScript promises in 10 minutes, followed immediately by 7 minutes of async await. And notice there's also async versus sync. So I'd say maybe if you're going through this and you're having trouble, start with the asynchronous versus synchronous programming. Then I would go to promises in 10 minutes. Then I would go to the async await. All right. Now notice it says here, You'll learn a lot more about promises later on in the module, so don't worry if you don't understand them fully yet. Even people who have been doing this for a long time at least sometimes get tripped up on this stuff. All right, async operations like promises are put into the event queue. Notice as it says, the event queue runs after the main thread is finished processing, okay? So they do not block subsequent JavaScript code from running. The queued operations complete as soon as possible, then return the results to the JavaScript environment. All right, so promises are a newer way of handling asynchronous program than callbacks. Callbacks can result, as it says in here, something that's referred to as callback hell, which actually has its own website on callbackhell.com. It's not very big, it's right here. But it explains how you can get into callback hell. All right, so let's take a quick look. So promises have similarities to the old style callbacks. They are essentially a returned object to which you attach callback functions, rather than having to pass callbacks into a function. However, promises are specifically made for handling async operations and have several advantages over the old style callbacks. 4 are listed here. One I've already alluded to, that first one. You can chain multiple async operations together with promises using the .then operator. All right, and pass the result of one or the output of one as the input into the next. This is much harder to do with callbacks. And as it says, it oftentimes ends up getting into callback hell where you've got a bunch of this. All right. Next, promise callbacks are always called in the strict order they are placed in the event queue. Third, error handling is much better. All errors are handled by a single catch block rather than being individually handled in each level of this callback hell pyramid. Finally, promises avoid inversion of control, unlike old style callbacks, which lose full control of how the function will be executed when passing a callback to a third party. All right, then we've got this nature of code, and then there's the active learning, so we're just about finished here. So it says, let's explore an example that further illustrates the nature of asynchronous code, showing what can happen when we are not fully aware of code execution order and the problems trying to treat asynchronous code like synchronous code. The following is a fairly similar example to what we've done before. One difference is we've included a number of console log statements to illustrate the order you might think the execution would continue in, would execute in. So let's run it. Try to run it. Close that. Let me close that. And I'm going to keep that for later. And I'm going to refresh. All right, notice I get an error. I don't even know if this, I don't even think this is the right one. All right, so let me refresh. It's not printing anything out right here. Let's see what they've got to say. How is that? The browser will begin executing code. See the first console.log statement starting. All right. Let's see if we can actually do something with this. Okay. So I'm going to grab this. I'm going to have to create my own image called coffee.jpg. So let's see if we can do this. I don't know if this will work or not. So I'm going to come in here. where we had the problems earlier. And I'm going to just paste this in right here. Not much code. It's all of it right there. All right. And I'm going to try to find a picture of coffee and save it as coffee.jpg. That'll work. In fact, let's do this one. I kind of like that. So I'm going to save the image as, is it a JPEG? Yes, it is. So coffee.jpg. I want to save it to where I'm working on my code. So that's in here. It's not in there. I'm sorry. It's I believe that I've got. So this is my async.html. Is there an async.html here? I'm not sure, but we'll save this to the desktop. And that's where I want to be in. There we go. There's our async. And there's coffee.jpg. Okay, so it should be there. And let's go and try to run this. And I'm still getting the problems with these CORS routines. All right. Hopefully this is something that's going to be resolved later. All right. If this confuses you, it says, let's look at this example. Well, since it didn't work, let's look at this example. All right, we've got a console.log registering click handler. All right, we've got this that says that when we click the button, all right, it should be running this. But my guess is that this one should run, then this one should run. This one does not run until we click the button. All right, it says this is very similar, and that's exactly what I just told you. It says the previous example works in the same way, except in the case of the second message is blocked on the promise chain. Okay, all right. In a less trivial example, this kind of setup could cause a problem. You can't include an async code block that returns a result which you rely on later in a synchronous code block. You can't just guarantee that it'll return it before the browser has processed the synchronous part. All right. I'm not going to go and give their example because it's given me some errors. All right. Now, and they talk about how you could fix this. All right. It says to fix the problematic fetch and make the 3 console.log statements appear in the desired order, you could make a third console.log statement. Try doing this now. Feel free to do that. If I've confused you, I sure as heck have not meant to do so. Also, I just want to mention to you real quickly, because like I said, I enjoy watching the videos by this Kyle Cook. You may or may not agree with that, but if I come back here again, and I again type in Kyle Cook, and I'm going to put in here CORS. All right. Well, I know it's in here because he just did this. Learn CORS in 6 minutes 2 days ago. All right. So have a look at that one as well. Maybe that's a better place to start. All right, in its most basic form, JavaScript is a synchronous blocking single-threaded language where only one thing happens at a time. Everything else waits until that one thing is done. That is mostly the way that this stuff gets taught, mostly in the AWD 1000 class, because what you're learning in there are both beginning programming concepts and client-side JavaScript. All right. But web browsers, as it says, define functions and APIs that allow us to register functions that should not be executed synchronously. Rather, they should be invoked asynchronously based on whether you know some kind of an event. As it says, it could be the passage of time, it could be you interacting with a mouse, it could be something coming back that you asked for from the network, it could be something else. This means you can let your code do several things at the same time without stopping or blocking your main thread. Really, again, one of the biggest advantages of using asynchronous code. Whether we want to run code synchronously or asynchronously depends on what we're trying to do. There are times we want things to load and happen right away. For example, applying user style defined styles to a web page, you'll want the styles to be applied as soon as possible. If you're running an operation that takes time, however, and again, quite often, this is going to involve a third-party external web API. So something, as it says here, like querying a database and using the results to populate templates. It's better to push this off the main thread and complete it asynchronously. Over time, as they mentioned, you'll learn when it makes more sense to do it one way as opposed to the other way. So that's it for this module. So next, we're going to jump into cooperative asynchronous JavaScripts using timeouts and intervals. And I'll be back with that shortly.